Welcome to our lesson on the general rule for arithmetic sequences, a rule that we use to find any term within a sequence. So sometimes you're going to be asked to find a particular term in a sequence. So a question might say, find the 100th term in the sequence below, and you have to be able to work forward 100 terms and find out what that value is. Of course, we don't want to do that one by one, and all the rules we've learned so far only allow us to do things one term at a time. So we're going to come up with a general rule today that we could use for any term. So we could just sub in, say, the number 100 if we wanted to find the 100th term and not waste hours doing it. Okay. So consider an arithmetic sequence where the first term is A and the common difference is D. So we've worked with those terminologies before. We would have our first term, so T1. Oh, let me just grab my highlighter. Remember, that's how we denote our first term. T1 is equal to A. T2, our second term, is T1 plus the common difference, D. Remembering the common difference is what we're adding each time. So you'd get the first one, add on the difference to get the second one. So if we're putting that in terms of our T1, which is A, it would be A plus D, and that would get you the second term. The third term would be whatever the second term is plus D. The second term was A plus D, and then we're adding another D, so it would end up as A plus 2D. The fourth term is the third one plus the common difference. So if the third one was A plus 2D, we're going to add another D onto there, and we'd end up with A plus 3D. And we could just keep going and going and going. But you've probably already noticed a pattern happening here. So our first one is A. Our second term ended up being A plus the common difference. Our third term, but just one of the common differences. Our third term ended up being A plus 2 lots of the common difference. Our fourth term ended up being A plus 3 lots of the common difference. So we're seeing a bit of a pattern form here. If we're finding, say, our fourth term, we're taking the original one and we're adding 3 lots of whatever the common difference is. And the number of common differences we add is always working out to be one less than whatever term we're on. So if we're on the fourth term, we get the first one and we add 3 lots of the common difference. The third term, we're getting the first one and we're adding 2 lots of the common difference. So you're taking your first one and you're adding one less than whatever you're on. So for example, if we wanted to find the 9th term, we would take our first term A and we would add one less than 9, so 8 lots of the common difference. So you can probably generate the formula yourself. However, I've written it nicely here for you. So at this point in the video, pause, copy down the rule that you see in front of you. So Tn, that just denotes whatever term you're on, or whatever term you want to work out. You can work that out by taking the first term A and adding on n minus 1 lots of the common difference. So if you're on n, you want to add n minus 1 lots of the common difference. Or you can write that in this format as well. It's the same thing. Over here we've used A for the first term. Over here we've just used T1. That's the only difference there. This you also get on your rule sheet, but it's nice to know how to use it and where it comes from. So the arithmetic sequence rule is right there. And they've written it like this. So just keep that in mind. If you're sort of doing your questions and using the A version, keep in mind A is the same as just the first term there. Okay, let's have a look at actually using this. So determine the 20th term of the arithmetic sequence 6, 17, 28, and 39. Okay, we have a rule. Our rule is T of n is equal to A plus n minus 1 D. There are some things we know. We know our A value. What's our first one? It's 6. We can work out what our D value is. So just by going, what's the difference between 6 and 17, 17 and 28. We're adding 11 every time. And just check that again, 28 to 39. Yep, we're adding 11. So our common difference is D. There's a difference of 11 between each of our terms. And we want to work out the 20th term. So our N is 20. All right, let's go and sub all of these things into this equation here. So T of 20, which is what the question asks us to find, is 6 plus N minus 1. So if our N is 20, N minus 1 is 19, lots of 11. So we have 6 plus 209. Oh, I haven't really left enough room, have I? There we go. 6 plus 209 gets you to 215 would be the 20th term of that arithmetic sequence. So much, much easier than going and physically plussing 11 20 times until you get to the term that you want. But again, not too tricky. And you don't even really need to remember the rule. Just know how to use it and what it means. It's on your rule sheet. Very nice. All right, your turn. So I would like you guys to determine the, let's say 40th term in the arithmetic sequence. I'm just using this notation for arithmetic sequence below. I can't call upon you guys to give me some ridiculous starting value. Oh well. Let's start with 3. 3, 7, 11, 15, and that's all I'm going to give you. So that's your arithmetic sequence there. I've got an ellipse to indicate that it's going forever. See if you can work out the 40th term. So pause the video, check back in when you're done, and make sure you got it right. Okay, I hope you paused the video. If not, probably sounded really silly. But here we go. Our rule, Tn is equal to, and if you need to check it, go back up to where we wrote it, A plus N minus 1 times by D. Our A value is 3. Our common difference, 3 to 7 is 4. 7 to 11 is 4. 11 to 15 is 4. Good. And our N, the one we want to work out is 40. Term number 40. Okay, so T of 40 is equal to 3 plus 39 is 1 less than 40 times by 4, which is equal to 3 plus 156. Again, I didn't leave enough room. I've not learnt my lesson, which gets us to 159. Oh, not 20. Our 40th term of that arithmetic sequence is 159. So not too hard. Okay, another way that we could see a question pop up is like this. So how many terms would we need to write down to find a term that's greater than 50 in the arithmetic sequence? So we want to work out, to have the value bigger than 50, what number term do we have to be on? And we've got this arithmetic sequence here, 10, 14, 18, 22. So let's write down everything we know about it. Well, we won't use the rainbow pen. We know our A value is 10. We can fairly easily work out our common difference. That looks like we're adding 4 each time. Yep. 10 to 14 is 4. 14 to 18, 4. 18 to 22 is 4. Good. And this N, well, we don't know it. What am I writing? Question mark. We don't know the N value. We want to work out what the N value is. And we have this rule. T of N is equal to A plus N minus 1 times by my common difference. We want the value, so our whole term, to be greater than 50. So we want all of this stuff to equal something that's greater than 50. So we could rewrite that as, well, A plus N minus 1 times D has to be greater than 50. So what N value, what term number, gets me to something greater than 50? Okay. Let's have a go. So subbing in what we know, 10 plus n minus 1 times by our common difference of 4 should be greater than 50. Let's take our 10 over to the other side. N minus 1 times 4 greater than minus 10, 40. Let's divide that by 4 to get the n minus 1 by itself. Again, I didn't leave enough room. Oh, and I've taken the 4s. Uh-oh. Let's give that another go. Left with n minus 1 is greater than 10. Add the 1 to the other side. Well, there we go. In order for our term value to be greater than 50, my n value has to be greater than 11. And we don't do half terms. We only have whole terms. So the next number term would be the 12th term. So 11 wouldn't get you to anything greater than 50. It has to be greater than 11. So our next one would be 12. So we would say, to answer that question, how many terms would we need to write down a term greater than 50? Therefore, we would need 12 terms to write down a term greater than 50. So that's probably the trickiest thing we've done so far with this concept. Another one that you could be given, the third term in a sequence is 12, the eighth is 37. Determine the first term and the common difference. Aha! So we don't have our A value and we don't have our D value. But we know the third term is 12 and the eighth term is 37. Bit of a weird one. You might look at this and not really know where to go with it. When that happens, write down at least the stuff that you know. We know there's a rule that's probably going to come in handy, so let's at least write that. Tn is equal to A plus n minus 1 times by D. Okay, we need to work out this, and we need to work out this. What else do we know? We know the third term is 12, so we know T3 is 12. And we also know T8 is 37. So let's sub these things in and see where we get. Let's work with, I'm going to call this the first one and this the second one. So let's work with the first one. My value of my term is 12. I don't know my A value. My n is 3 because I'm on the third term, which means n minus 1 is 2. Okay, so we've got something we might be able to work with. We've got two unknowns though, so there's not much we can do with it at the moment. Let's just leave it there. And we'll have a look at our second one that we've got there. So T8 is equal to 37. So the value of my term is 37. And following this rule up here, we don't know our A. We're on the 8th term, so n minus 1 would be 7. D. Oh. Okay, haha. Our favourite topic, simultaneous equations. Let's have a look at that. Let's take this 2D over here. So 12 minus 2D is going to equal A. I'm going to now sub that value into here, and when I do that, I'll have 12 minus 2D written here, which means the only unknown I have left on this side of the equation is D, which means I can solve it, and then I can sub it back in and find A. So, our favourite topic, simultaneous equations, comes up again. 12 minus 2D plus 7D is equal to 12 plus 5D. 37. Take our 12 to the other side. 37 minus 12 is 25. And dividing by 5 to get D by itself. Yay, our common difference is equal to 5. That makes it really easy now to solve for my A value. I know my A value is 12 minus 2 lots of the common difference if I sub it back in up here. So let's go and do that. I apologize for the messy working out. 12 minus 2 lots of the common difference of 5 is our A value. 12 minus 10, 12 minus 10 is 2. So our A value is equal to 2. There we go. The question asked us to find the first term and the common difference, and we've done that. I would say therefore, oh whoopsies, but not right in highlighter. Therefore, A or T1, whatever you'd like to call it, is 2. And the common difference is 5. And that's the question answered. That's probably as hard as it's going to get, guys. Like, that's really incorporating a few different topics together. One more example that we're going to go through before the lesson finishes up, and that is another graphing question. So kind of like what we did last lesson, or the lesson before. I can't quite remember when we did the graphing. But we're going to do another little example here. So an arithmetic sequence is defined as, so this is our relation that we have for our arithmetic sequence. Tn, so any term n, is equal to 11 minus 7 times n minus 1. We want to graph the sequence. Guys, this is no different to graphing any other linear equation that you've ever had before. It's going to be linear. When you have a common difference, you're increasing or decreasing by the same amount every single unit that you go across, which means it's going to be linear. Like the rate that it's increasing or decreasing doesn't change. It's just a linear equation. So don't be put off by the term arithmetic sequence and graphing it. It makes it sound hard when it's really not. Easiest way to do this is probably just to make up a little table of values. So sub in for your first term, your second term, your third term, your fourth term. It doesn't really matter. It's just linear. You just need a couple of points. Join your dots. We're going to do 5 today. You don't need that many, but just to make it really clear what we're doing, we're going to plot those points on our graph, and that's it. So let's go. We want to find T1, T2, a third term T3, fourth and fifth. So that's the number term I'm on, and my actual value is for T1, let's sub in 1. My equation is 11 minus 7 times by n minus 1. 11 minus 7 times by 1 minus 1, which is 0, is 11. Okay, my second term. I probably should have made this table a bit clearer, just to avoid any confusion. 1, 2, 3, 4, 5, and then I write under here T1 is equal to 11. Okay, T2 is 11 minus 7 times by 2 minus 1 is 1. 11 minus 7 is 4. T2 is equal to 4, and so on. We repeat this process. Now, I'm not going to show the working out for all of them because I'm sure you all fairly well understand that at this point. I'm just going to pop them in the table. So chucking it in the calculator, 11 minus 7 times 2. Negative 3 would be the next one. The other thing we can do here is start recognizing how many it's going down by. Going down by 7, going down by 7. So now we can kind of just take 7 off each time. Negative 17. So we have a table of values. We can graph that. Before we do that, just have a look at your numbers. 11, 4, negative 3, negative 10, negative 17. You can see they're going down. You could have recognized that before we even worked them out. Keep in mind, this is literally just a linear equation. This is our variable here. You can think of that as your variable x. The thing attached to the variable is negative 7, so that would be our gradient. And then over here, this positive 11 would be your y-intercept. if it was a normal linear equation. But the important thing to note is this -7 here. So -7 being your y-intercept, it's a negative. We would expect the numbers to go down, and they do. So we must have done something right at least. And we're going to expect them to go down by 7 each time. And if you're comfortable with recognizing that, and you can see they did go down by 7 each time. If you're comfortable with recognizing that over here, you don't really need to show the table. You can say, because the gradient is shown to be -7, I know that my numbers are going to decrease by 7 each time, and therefore here's my values. Let's go and graph them now. So for T1, T2, actually, let's just write 1, 2. This can be our n-axis. 3, 4, 5. Obviously, use a ruler. And our next ones are, we want to start at 11 and go all the way down to -17. So let's go in 5s, 15. All right, 5, 10, 15, -5, -10. Pick a scale that works. T1 is 11. We'll go and put a dot there at 11. About there. T2 is 4. About there. T3 is -3. About there. T4 is -10. There. And T5 is -17. So around about... I didn't do my axis very accurately, but you can see you've got a linear form of points there. We don't put a line through them. We just leave them as points. So keep that in mind as well. And that's it, guys. So all we've done today is find the general rule for your arithmetic sequence, use that to predict any number within a sequence, and we kind of used it in a few different types of scenarios as well, so expect to see it like that. And then we've done this graphing of the arithmetic sequence at the bottom. So make sure you know how to do all of those things. As always, ask questions if you need, and good luck, have fun.